Welcome to the topic called simple machines. This topic is covered in 4 courses. We have level 5 mechanical production, then we have level 5 automotive engineering, then level 6 automotive engineering. So in level 5 it's called mechanical science principles. Automotive is called automotive engineering science. Those are the names you are able to see here. Then level 6 is also called automotive engineering science. Then number 4 here is also done in agricultural engineering. Level 6 you'll also find a number of them. The number of hours for the entire course is here. This is not for the topic, but it's for the entire unit, mechanical science, automotive engineering science, for the entire unit. So I have some subtopics I want you to be posing. It's simply a question and answer of sampled questions from the topic, but majorly 90%, let me say 98%, because the questions were well researched. 98% of these questions will be examined. So once you revise all these questions, there's no way you'll find a question that will throw you off balance. It's covering everything. So here we tackle work, power, energy, machine, which also refer to it as simple machine. We define mechanical advantage, velocity ratio, and efficiency. We describe examples of simple machines. As you can see, they are lined up here. We study the law of machine and the formula, how to do it, how to derive the formula from the graph and also from calculation. So question 1 is here. You just pause and you go through the definition of terms, the classification, the forms of energy, difference between kinetic energy and potential energy, the law of conservation of energy, transducer, the definition, and we have a few examples like number 2. The table below shows charts showing how energy is transformed from one form to another. So you study the chart and answer the question that follows. So the chart here is simply giving you an example of transducers and how they transform the energy from solar to heat. You can see we have a solar panel, all the way to chemical to electrical, which you have a battery. So just study that, then attempt to describe the transducers below. A car battery is used to light a bulb, so you describe from which energy. Like a car battery, it starts all the way from chemical energy, then it ends to a bulb in light and heat. But now in other videos I'll be doing for question by question now to explain, because I know some people have a challenge. Maybe defining work you can get directly from the note, define joules, but when it comes to calculation like F, G, H, some people, probably if you didn't do physics at high school level, you would have a challenge. So this again is a transducer. Name the transducer that is used to convert from maybe sound to electrical. Like you can see a microphone receives sound and it converts it to electrical. But on the other side we had also given one like this, Roman 3. It receives electrical, then it gives you sound energy, which is a loudspeaker. So once you study that chart, you are able to do that. So these are question on work done. Then number 3, we are now looking at gravitational potential energy, elastic potential, kinetic energy, potential energy. So as you move down, you just pause the video, you answer the questions where you have a challenge. Probably the calculation part is where I'm sure that most people will have trouble. Just reach out through the comment section. But the videos for probably each question will be following. So there are questions on finding the power developed and the efficiency. These are very, very common questions in exams. Then we have question 6. Now simple machines, handling them one by one. You need to know how to get the velocity ratio for each and every simple machine. It's done uniquely. For a lever, it's not the same as a pulley, is not the same as a hydraulic press. So each one of them, so you also need to know how to differentiate the 3 classes of lever. Then You also describe how to locate the velocity ratio of a wheel and axle. Just like I've said, they are done uniquely. So you just pause, you work out what do you understand by the term pitch of a screw, then find the velocity ratio of a screw. They are quite very nice questions. Then the pitch screw is here. You calculate the velocity ratio. I think the question has been above here. The questions are here. Then the diagram is below, so you can use it. Remember, here the values are given in centimeters, so take note of that. Then number 7, how do you find the velocity ratio of a gear system? What is a pulley? Then it's important, you can be asked to draw a pulley system with velocity ratio 1, 2, 3 all the way to 6. In case of any challenge, you just reach out. These things are very important. Then we have an example of a hydraulic machine. Then you have been asked to, so you pause, get the diagram, then you answer the questions below. Here we're talking about finding the effort needed, the energy wasted. Very important, and you'll meet these ones very often. Now there's a combination of a lever, there's a pivot. Then down here we have a hydraulic machine. Take note that the values are given in square centimeters, so that you do not miss out and fail to score. So the question I mentioned on the law of the machine, you can be given a graph. You see here you're supposed to plot a graph of force against load. Then from the graph, the y-intercept gives you the value for B, and the gradient gives you the value of A. So the law of the machine is this. So the y-intercept gives you B, then the slope gives you A. You substitute them there and you've gotten the law of the machine. You can also be asked to that answers Roman 2. You can also be asked to calculate the limiting efficiency, which the students have taught, we have done in class, and I know once we do it together through the videos, you'll have no problem at all. These are transducer, just a repeated question because there have been many in past exams. Derive the kinetic energy equation. Then we have a question on power, law of conservation of energy. Then you pause. So there's a question on the law of the machine now. Here now you, from the velocity ratio is given, then from these two tests you form two simultaneous equations and solve them simultaneously to get the value of A and B. Then you substitute in the equation I've mentioned above. So you'll either be given a question on a graph or this one that involves calculations. Very important. Then number 9, again the law of the machine. This simply stresses on how important the law of the machine is. So it's very important. You go through it very well. So these ones I didn't type, I just copy pasted from some exams. You can see that we have a pulley. We're supposed to find the force ratio. Force ratio is simply the mechanical advantage. Then the movement ratio is simply the velocity ratio. So take note of that even as you are calculating. Then the pulley is there, so use the pulley to calculate the velocity ratio. We said you count the number of belts or strips, ropes that are supporting the load. For these ones are 6, so VR becomes 6. So you just attempt. Then we have another question. Again here on, you need to define the terms effort, load, mechanical advantage, velocity ratio, efficiency. Then you use the machine down here. I think I had also given an example of the same. Up there again, here the values are in centimeters, so it's very important you know how to get all this. We have A1 here, A2, the effort, X, Y, this is the load. So it's very important you go through and be able to understand. Okay, there's another one here, highlights 4 simple machines, supposed to be machines used to make work easier. Then we have this looks like a car jack screw. So just copy the first part of the question, then you let the video move. So then you pause again to get the diagram. Then you need to find the velocity ratio and mechanical advantage. Then you proceed further. Another one again I copied from an exam. You can see it was number 17. Again they're emphasizing on the three classes of lever. And again, the figure below shows the 3 levers. So what are you supposed to do? Pause the video, then you check. You're supposed to calculate FA, FB, FC, MA and velocity ratio in each of the cases. You can see it's carrying a lot of marks, 12 marks. So, okay, that was the last page. So you have those questions. Imagine there are 12 good pages of simple machines. So once you study and revise these questions very well, especially through the notes I provided in class, you will be able to answer all these questions. And in case a question is brought from this area, 20 marks, you can really swim in those 20 marks and really excel. So that is all about simple machines. In high school we call it work energy power and machines. In TVET we call it simple machines. It's very interesting. I'll be uploading the workings for the same. Have a good time as you study engineering.